So the typical methods that geologists use to date rocks are what we call radiometric dating. It's actually a whole set of different methods. So radiometric dating relies on the decay of naturally occurring radioactive isotopes that we find in rocks. So imagine you have the eruption of a lava flow from a volcano. Within that lava, there will be radioactive elements, things like potassium-40. And as the rock cools below a certain temperature, these isotopes, which are decaying and giving rise to stable daughter products, the rock will begin to accumulate daughter at the expense of the decay of the parent isotope. And so geologists today collect samples of those rocks, they do a chemical analysis, and they look at the ratios of those radioactive and stable isotopes, and they use it as a kind of clock to infer an age. So you have to understand that there is no clever machine in a laboratory somewhere where you can put a sample of a rock in and out, the ticker tape comes out the other end and there's an age of a rock. The age of a rock is an interpretation of a chemical analysis of a rock or a mineral. And of course, the interpretation is only as good as the assumptions that go into your interpretation as an age. And so we want to know what were the initial conditions. For example, was there any daughter product in the rock to begin with, or was it all the result of the decay of the radioactive parent? What about the rate of decay? Was the decay always constant, as we can measure it today, or has it changed in the past? What about contamination? Have any of these isotopes entered or left the rock during the history of the rock, while it's been there sort of in the ground before we come and collect the sample? All of these assumptions are questionable and can be challenged in different ways. So, for example, you can go to places today where there are lavas of known age that are formed in historical times, and if you date them using these radioisotope methods, they will give answers in millions of years. And that's because there's been some contamination of the samples, some inheritance maybe of daughter products, or maybe some daughter products were retained in the rock to begin with. The rock didn't completely sort of degas and get rid of all of its argon or something of that kind. So we know that these assumptions are questionable, and it calls into question your interpretation of an age. If we know that these assumptions are questionable when we have samples of known age, what about when we have samples where we don't know the age? How can we rely on the assumptions then? So we need to be critical about these dating methods and the results that they give us.